Okay, so we have a volume formula separate from the regular volume formula of a cylinder. So we have that V equals negative t squared plus 12t plus 24 pi. I'm going to leave off the meters cubed because, nobody cares. We can figure out what the volume is at t equals 4. So that's going to be negative 4 squared plus 12 times 4 plus 24. Do all that. That's going to equal pi. There's a pi in there. Equals 56 pi. At t equals 6, the volume is going to be negative 6 squared plus 12 times 6 plus 24. All of that times pi. That's going to equal 60 pi. For a difference of 4 pi total, 4 pi cubic meters. We also find out in the problem that in the space of 2 minutes, it goes from a distance of d meters of unused space. So we can treat that part as a cylinder all of its own. There's a cylinder of empty space. In 2 minutes, it goes from d to 1/3 d. Therefore, the height in that 2 minutes, the height of the water that filled up in 2 minutes is 2/3 d. Because it went from, we have the empty space that went from d to 1/3 d. So the water that filled up in the meantime, in these 2 minutes between t equals 4 and t equals 6, is 2/3. That's supposed to be a third. 2/3 d. We can now figure out the volume of this cylinder of water that it just filled up in that 2-minute period. So remember, the volume of a cylinder is pi r squared h. We know that, well, we have pi. The radius of the cylinder is the radius of the tank, so that's 3 squared, and the h is going to be the 2/3 d. And we know that that equaled 4 pi from this difference. So we have these two guys here going into this equation. So from here, so it's pi times 9 times 2/3 times d equals 4 pi. Okay, so you solve all of that all the way down for d. You get d itself equals 2/3. So from there, we can actually just plug these values into the rest of the equation. Remember that we're trying to find the height of the tank. So the height of the tank is going to be the real height, the height of the volume of, or the height of the regular water part of the cylinder at any given point. Actually, it's going to be easiest to say the height at 4 minutes, the height of the water at 4 minutes, so the volume with the height at 4 minutes plus the volume of the cylinder at d equals the total height of the tank. And we know that the volume at that point was 56 pi, so we need to figure out what the height of the cylinder was at that point. So we use our volume equation once again. So pi times the radius squared times the height equaled 56 pi. We know that the radius is still 3. We get 9 times that height equals 56. The height equals 6. So back to our cylinder here. At time of 4 minutes, we have a cylinder of water and a cylinder of air above it. We now know that the height of the cylinder of water was 6, and we know the height of the cylinder of air is 2/3 of, these are meters. So those two things added together, 6 and 2/3 added together. Oh wait, sorry. The height doesn't equal 6. That's terrible. The height equals 56/9. All right, so right, yeah. So here, the height of the cylinder of water is 56/9. 56 ninths plus 2/3 equals the height of the entire tank. And from there, those two things added together, it ends up equaling 62 ninths, which equals 6 and 8 ninths. Answer choice B.